In this video, I am going to explain about multithreading. Normally, the performance of the processor or the speed of the processor is measured by the number of instructions executed in one cycle. The rate of instruction is given as clock frequency into number of instructions per cycle. That is to improve the performance of the processor or to increase the speed of the processor, we can increase the number of instructions executed in one cycle. Either we can increase the clock frequency. The number of instructions executed in one clock cycle can be increased using the technique pipelining. So multi-threading is the high degree of instruction level pipelining or instruction level parallelism. To know what is a thread, first we have to know what is a process. The entire application program is divided into instruction streams, that is called process. An instance of a program running in a computer is called process. That instruction stream or process is further divided into several smaller streams, that is called as a thread. Each thread is assigned a single task to perform and executes independently. For example, you consider the Microsoft Word application. That is the entire process. While typing some content or text in the Microsoft Word, some thread is checking the spelling of the words, and some thread is checking the sentence format, and some thread is saving the content which is typed in the Microsoft Word. So in the Microsoft Word, many threads are executed simultaneously to complete the application. Multi-threading means multiple independent threads are executed simultaneously by the operating system. The multi-threading shows the ability of the central processing unit, that it shows how the central processing unit executes multiple independent threads simultaneously. In a single processor system, multiple threads share the CPU time. So this improves the performance of the CPU by maximum utilization. It reduces the idle time of the central processing unit. Some examples for multi-threading is, one is web browsers. A web browser can download any number of files and web pages, that is multiple tabs at the same time, and still lets you continue browsing. If a particular web page cannot be downloaded, that is not going to stop the web browser from downloading other web pages. Next example, web servers. A threaded web server handles each request with a new thread. There is a thread pool, and every time a new request comes in, it's assigned to a thread from the thread pool. Another example, consider computer games. In that games, many objects like cars, humans, birds, which are implemented as a separate threads. And next example is text editor. When we are typing in an editor, spell checking, formatting of text, and saving the text are done simultaneously by multiple threads. There are three types of multi-threading. One is coarse-grained, fine-grained, and simultaneous multi-threading. In coarse-grained multi-threading, the switch between the threads takes place in case of a catchy miss. For example, consider two independent threads named as thread A and thread B. If an instruction in thread A is executed in clock cycle I and clock cycle I plus 1 and I plus 2. In a clock cycle I plus 2, we are executing a load instruction from thread A. So this load instruction will consume some time. So the processor will be in a idle or stale condition. So that is called as a catchy miss. In that case, a thread scheduler is invoked and it switches the control from thread A to thread B. So the instructions from thread B will be executed. So in this case of coarse-grained multi-threading, switching between the threads takes place in case of catchy misses. Control switches from one thread to another thread in case of a catchy miss. Next type, fine-grained multi-threading or interleaved multi-threading. For example, consider two independent threads, thread B and C, are executed simultaneously. Means in clock cycle I plus 1, instruction from thread B will be executed, and in clock cycle I plus 2, instruction from thread C will be executed, and in the next clock cycle I plus 3, instruction from thread B will be executed, and in clock cycle I plus 4, instruction from thread C is executed. So the instruction from thread B and C are executed in alternative clock cycles. Simultaneous multi-threading. In this simultaneous multi-threading, in a single clock cycle, instruction from thread A, thread B and instruction from thread C are executed simultaneously. Thank you.